All right, welcome to another lab for grade 9 advanced science. This is actually not a full lab that we would do in the course, but it's something that we would do as part of another lab. We're here today to look at crystal shapes and how to examine crystal shapes for different solutes.
Okay, so the solutes that we're using today are going to be naphthalene, potassium nitrate, sodium chloride, and a mixture of potassium nitrate and sodium chloride. Our solvents that we're using in this lab are 2-propanol. So we've got 2-propanol. And
so 2-propanol is also known as rubbing alcohol or isopropyl alcohol.
Okay, and our other solvent that we're using today is water.
So what we'd like you to do at this point is pause the video if you've taken grade 9 advanced science and decide which solvent, the alcohol or the water, would be best for each of these different solutes. So which solvent would you use to dissolve each of these solutes? Pause the video and see if you can decide. So Ms. Watts, which solvent would you choose for naphthalene?
Okay, so based on our alcohol as a solvent lab, you should have found that naphthalene along with BHT are soluble in an alcohol. So for naphthalene, we are going to dissolve it in 2-propanol.
And it doesn't matter which alcohol. In that lab that we had done with alcohol as a solvent, we also used methanol as a solvent. So if you had some methanol, you could also use that, right? But for the other solutes, these are all salts. So potassium nitrate, sodium chloride in the mixture. And you would remember from that same experiment that salts are not soluble in alcohols, but they're very soluble in water. So we're going to use water to dissolve these three substances, and we'll use the alcohol to dissolve the naphthalene, right? So I'm going to take a test tube. I'll take the potassium nitrate to begin with. Now the potassium nitrate that I'm using is in a form that's sort of little beads of potassium nitrate. It's got little round beads in it. It doesn't always look like that. Sometimes it's a crystalline salt, sort of like table salt. It can change how it appears in the solid form. But this one is little beads. I'm just going to pour some or all of that into a test tube, and I'm going to add some distilled water, and Miss Watts can do the same thing with her solution.
Okay, the naphthalene, which looks a little bit different from the other solutes, is a little bit more of a flaky appearance before we dissolve it.
I think it has a bit of a yellowish color too, a little off-white. But again, the appearance could be a little bit different. You can't totally go by that. And you're using about 10 mils or so of water for me and about 10 mils of alcohol for Miss Watts. Now one thing I'm noticing is as I dissolve my potassium nitrate, the solution's feeling cold. So as it feels cold, this dissolving must be an endothermic process. We don't have to dissolve everything, we just want to dissolve some salt. In fact, we don't want the concentration to be too high, do we, Ms. Watts?
We don't want the concentration to be too high, or the outcome of this experiment won't be what we're hoping for. We don't want to have a really highly concentrated salt left over or solute left over on our watch glasses at the end. We want to be able to see hopefully individual crystals form rather than a clump of solute.
That's right. So you want a relatively low concentration. So if there's some salt that isn't fully dissolved, that will be okay. Now Ms. Watts just used a term that we may not have heard before, the term watch glass. So a watch glass is just a piece of glass that is shaped like this into a sort of maybe a lens shape. It's concave, and I've written on this one in Sharpie potassium nitrate and sodium chloride, and we've labeled them all. So make sure you know the name of this piece of lab equipment, a watch glass. It's named that way because we're going to watch the crystals form on the glass and examine them once the liquid has evaporated. So we're going to pause the video while we create the other solutions, and we'll come back and we'll put them onto the watch glass. So we've made our solutions. We haven't bothered to try to dissolve all the solute, so there might be a little tiny bit of undissolved solute at the bottom. That doesn't mean it's saturated, it just means that we didn't shake long enough. The potassium nitrate crystals are quite large, so it would take a longer time shaking. Remember, you don't want to use concentrated or saturated solutions. You want the solutions to be dilute. So what's the next step, Ms. Watts, to grow crystals to examine them?
Okay, so the next thing that we're going to do is unstopper and decant our solution onto the watch glass. And just to recall, that is an important word for you to know. When we're decanting a liquid or a solution from a container, we're just trying to pour off the solution and leave behind any solids that remain at the bottom of the test tube.
Yeah, so we don't want any solid salt on the watch glass, right? Just
That's
the
right.
solution. So I'll decant the mixture, and Ms. Watts can start from the other end and decant the solution of naphthalene. Now, Ms. Watts, we've labeled the watch glasses with Sharpie in blue, and the Sharpie is permanent, so it doesn't dissolve in water, but the permanent Sharpie does dissolve in alcohol. So we're going to get Ms. Watts to pour it in just to the center of the watch glass. All right, so there's the naphthalene. I'm going to take the sodium chloride and decant into this dish, and we'll do the potassium nitrate. So we don't have to fill the dish. We just want to pour some solution in the center of each watch glass, and we're going to let this evaporate overnight. If you're doing this lab, it usually just takes one night for that little bit of liquid to evaporate, right, Ms. Watts? Some students are impatient and they want to look at crystals by heating them quickly. Can you describe the problem with that?
So if you recall from our lab where we were trying to determine the solubility of a certain salt at a given temperature, when we were evaporating the water in an evaporating dish, we were able to see the solute fairly quickly by heating using that method. But you might recall that there was a crust of solute that formed, which for some of you are able to just remove as one solid piece. That doesn't allow us to view any individual crystals, but rather just this clump of solute.
Yeah, so we want to see here tomorrow individual crystals of the salts so we can examine their shapes. So two things, you want to use a dilute solution to do that, and you want to let it evaporate slowly to form those crystals. So we're going to stop the video here, and tomorrow we're going to come back and examine the watch glasses to see what the shapes of these crystals look like. And this is an important experiment for the sludge tests if you end up doing that experiment where you might have these different solutes in your sludge mixture. This is one way to identify them, by looking at the shapes of the crystals that they form when they precipitate after evaporating overnight. So it's been just about 30 minutes since we laid the watch glasses down, and in that time the alcohol that was used to dissolve the naphthalene has fully evaporated. The water that was used to evolve the salts is still evaporating. That's going to take all night. But while we're here, why don't we take a look at the naphthalene watch glass. So you can just see from a distance the solid that is precipitated onto the watch glass. I'll pull that up to the camera so you can see a little bit better. So those are the crystals that have formed when naphthalene precipitated. We dissolved it in rubbing alcohol, 2-propanol, and let it evaporate. Again, the concentration wasn't that high. If the concentration were much higher, we'd have really just a big clump of crystal. Now the crystal shapes are not that clear here. Naphthalene basically forms sort of a generalized white crystalline precipitate. Sometimes it has a bit of a pattern to it, but there's really no characteristic shape. There's maybe a little tiny bit of needling along the sides there. I don't know if you can see that, but not really anything that's easily described. Now, the reason I wanted to show this now after just 30 minutes is because we're going to leave it overnight. However, naphthalene does have a tendency to sublime. So you remember sublimation means that the solid will turn directly to a gas. So sometimes you get crystals of naphthalene, you come back the next day and they're gone. They're gone because the solid turned directly to gas and essentially escaped from your watch glass. So you want to be able to look at those as soon as they form. We're going to use a microscope tomorrow to examine them, and we'll show you under a microscope what the different crystal shapes look like. So you'll get a bit of a better sense under the microscope.
Okay, so here we are on day 2 of the lab. And so what we're going to be looking at today is what was left over after one full night of letting our solvents evaporate and the crystals form. So each of the different solutes is going to have their own unique crystal shape. And so we're going to start with naphthalene. So you might recall from earlier, Mr. Patno had mentioned that naphthalene can sublime. So what happened yesterday before the end of the day was that the methanol, which we had used as the solvent,
2-propanol,
or 2-propanol,
the alcohol,
the alcohol, which you used as a solvent, had completely evaporated, leaving behind the solid naphthalene. When we came back on the second day, no naphthalene was left on the watch glass, so it did in fact sublime.
So the solid crystals completely disappeared and turned to gas. The naphthalene gas escaped.
Okay, so what happened was this morning, so on day 2, a new solution was prepared on the watch glass and the alcohol was allowed to evaporate before the naphthalene was allowed to sublime, and what we're left with now are the characteristic crystal structure of the naphthalene.
So the naphthalene crystal, maybe you can just put that back there for 1 sec, Ms. Watts. The naphthalene crystals, it's hard to describe their crystal shape in a simple way. When you get some really nice crystals of naphthalene, sometimes they have a bit of a leafy look to them, like the branches of a leaf. But otherwise, they kind of often just take this sort of random, a little bit hard to characterize, hard to describe, other than a white crystalline solid. Okay? They don't really have an easily described shape compared to the other ones that we're about to see. So the second solute that we used was potassium nitrate, and you remember we dissolved it in water. You can see here from a distance, you can already probably see the shapes of the crystals just with the naked eye. We'll bring that up closer to the camera. Normally, you would, in the lab, you would use a microscope at this point if you were doing a sludge test, and you would take pictures of your crystal shape with the microscope and your cell phone. But can you point out there, Ms. Watts, what we're seeing in the middle of the watch glass?
So in the middle of the watch glass, we see needle-shaped crystals here for the potassium nitrate. The solution was maybe a little bit more concentrated around the outside, which is why you can't see those individual crystal shapes.
But it is very clear to see long needle-shaped crystals in the middle of the watch glass. So that's something you want to note for yourself. Potassium nitrate, KNO3, forms a very characteristic needle-shaped crystal when it evaporates. The next one was pure sodium chloride, which is table salt. And just from a distance, you can see this solution was probably too concentrated when we did it. The watch glass is covered with a salt precipitate. But if we look closely, and again, a microscope is good, but if you look very closely in the middle of the watch glass, what do we see here, Ms. Watts?
Okay, so sodium chloride forms a characteristic cube-shaped crystal. So you can see many cube-shaped crystals in the center of this watch glass. And again, where it was maybe more concentrated, you can't see those individual structures around the border of the watch glass.
So some students will call these square-shaped, but remember you're looking at the top of a cube. If you imagine just looking at the top of a cube, yes, it's a square, but remember this is three-dimensional, so the proper term is that these are cubic-shaped crystals. So be sure for grade 9 advanced science that you know the type of crystal shape formed by those two salts. Potassium nitrate, needle-shaped crystals, and sodium chloride, cube-shaped crystals. Sometimes when you buy table salt at home, you can get the very fine crystal powders of table salt, and the crystal structure is really not that visible. But if you get the coarser salts, like the kosher salt, when you use it, you can often see those little cubes just with the naked eye. So the last one, Ms. Watts, is a mixture of potassium nitrate and sodium chloride. So I think I can anticipate what we should see here. But let's see if it's actually visible. Again, this solution here is maybe just a little bit too concentrated, but I think we can still see that pretty clearly. What are we looking for here?
Okay, so you can see sort of mixed together, we have these long needle-like structures from the potassium nitrate, combined with some cubic-shaped crystals which represent the sodium chloride.
Yeah, so when you have a mixture of the two salts, you get a mixture of the crystal structures.